All right. Hi, everyone. Welcome. Welcome to the Container State of the Union. My name is Deepak Singh, and I run the containers org for AWS. If you've been to reInvent before, you've probably heard me do this a couple of times. First of all, thank you. It's Thursday. It's a Thursday after a pub crawl. It's a Thursday after a keynote, which is not in this hotel. So for those of you who walked all the way, really appreciate it. Now, when I gave this talk this time last year, we were starting to see the first meaningful production workloads come onto containers on AWS. Some people had started a couple of years ago. There's been folks who've been using containers for a much longer time, but really last year was the first time we started seeing multiple customers starting to run meaningful workloads on containers, and in our case with ECS primarily. But it was pretty clear that containers are a thing. They weren't just this fad that had started because a bunch of geeks liked it. And there were people who were starting to build real meaningful applications. They were starting to ask for more and more features that are relevant to running applications in production. So in many ways, it's kind of nice that customers of ours who've grown up on EC2 and who had started building these architectures, and this is kind of what happened. You had folks like Netflix, because Adrian's the one who said this, who had started building what they called, and I guess now are called cloud native architectures, decoupled applications, using managed services when possible, taking advantage of the fact that AWS has multiple regions, taking advantage of the elasticity. And along the way came containers, and this is my assumption, seems to at least be like that, is that containers made this transition from monolithic applications to cloud native applications a little easier for many people. And as the tooling became better and better, as the software and management services that they had around containers got better and better, our customers started taking this journey from containers, from building things on EC2, potentially putting them in JVMs, to running them in things like Docker. Last year, we had Will White from Mapbox talk about the journey that Mapbox had taken and the reasons that they had started running on containers, the ones that you usually expect. So how has a customer like that evolved? And they've had a bunch of experience running containers in production over the last couple of years. So to talk about how Mapbox has gone from building and growing the container-based infrastructure to the lessons that a customer that's been experienced with running containers for a couple of years has, and some of the non-obvious lessons of running containers, I'd like to invite from Mapbox, Franziska Schmidt.
Hi, everyone. I'm really excited to be here today. Thank you, Deepak, for the introduction. So Mapbox has been on a journey of migrating to ECS over the last year. So if you asked 10 developers why you would want to containerize your infrastructures, chances are the answers you get are going to get something like this: cost reduction, developer productivity, and faster scaling. And those are the reasons why Mapbox decided to migrate our infrastructure as well. Like Deepak said, a year ago, we were on the stage talking about how we're going to start our journey, and now I'm back to tell you about how it went. We're now running 95% of our infrastructure on ECS, and through this journey, we found some non-obvious or hidden benefits that we didn't anticipate when we started out, and I want to share those with you today. So my name is Franziska. I'm a platform engineer at Mapbox. So the reasons we decided to migrate to ECS, like I said, number one, cost savings. We knew that running on ECS, we would be able to place multiple tasks on any EC2, therefore really simply just cutting down our bills. Number two, fast and more flexible scaling. As a startup in the kind of web traffic space, we have to be able to respond to incoming waves of traffic really quickly without being overscaled at all times, because that would be a waste of resources and money. ECS allows us to scale by starting up new containers and tasks in a matter of seconds. Whereas on EC2, of course, it's a matter of, in a ballpark of minutes to boot and provision a new EC2. So that was a really interesting benefit for us. And number three, increased developer productivity. Of course, since Docker launched, it's become really obvious to many people that Docker is just a great tool for developers to become more productive by reducing iteration cycles from being in a development environment to production. And we wanted to reap those benefits for us as well. There's a few non-obvious benefits, and I'm going to go into each of these in more detail in a second. So Mapbox is a mapping and location platform for developers. We offer a range of tools that you can use to build mapping and location services with your applications. We have map services that render beautiful maps. We have geocoding and directions APIs. And we have developer tools such as SDKs for iOS and Android. And we recently even launched a Unity SDK that you can use to make games with maps and locations, which is super cool. Our traffic and production systems look something like this. We have processing jobs, which are batch processing jobs and data analysis jobs, and we run those with the ECS run task API. So for example, we have a pipeline that gets input data from OpenStreetMap and uses this to render beautiful maps. And then we have API services, which are just HTTP web services that respond to user requests. So for example, we have an API map service that gets requests. Let's say I want a map tile for a certain coordinate and with a certain map style. What does the traffic look like on these both two types of services? So on the processing side, we run up to 70,000 tasks within 1 hour. So those might be long-running tasks that have gone for days, or short tasks that run only a matter of seconds. We have up to 200 EC2s at peak on the processing side, and these clusters are running in 2 AWS regions. On the API side, it's a little bit different. We have 500 to 15,000 tasks and containers in any given clusters, which corresponds to a number of 40 to 200 EC2s. And our API services are currently co-located in 7 AWS regions, which is cool. So we're running all over the world in different regions in the US, Ireland, and Asia Pacific, like Singapore. So let's look at these benefits. The first one is open source private infrastructure. So when we started migrating to ECS, we started thinking about how we can manage our repositories in a way to adapt them to ECS. And what ended up happening is that we separated a lot of the infrastructure code from the actual application code. Since now our service developers didn't have to think about how to boot or provision an EC2, we removed that code from the service repositories. This was beneficial in a variety of ways. Our service developers didn't need to touch the infrastructure scripts anymore. We also, therefore, centralized the infrastructure scripts, putting all the ECS-related code in one place, which was much easier for us platform developers to manage. And it had this sort of side benefit that we could now open source our application code a lot easier. Since all of the infrastructure-related craft code, let's say, was removed from the application code, made it much easier to open source things. And we open sourced a variety of repositories that you can check out on our GitHub at Mapbox. So migrating to ECS helped us separate our infrastructure from the core domain code, which is beneficial in multiple ways. Next, consistency across the organization. So when we started migrating to ECS, we touched, of course, all of our repositories and tried to adapt them to work in a container. So the first thing you do when you try to do that is normally like writing a Docker file, and then maybe some more ECS-related things. Like any developer would do, we noticed that we were kind of writing the same code over and over again, so we wrote a shared library to handle this for us. This library is called ECS API, unfortunately not open source yet. It's a CloudFormation helper library for setting up ECS-based HTTP APIs. And setting this up for all of our API services turned out to be really great help to have more consistency across our code bases. So we have now better patterns and conventions for best practices across our ECS use. We were able to reduce the copy-paste shared functionalities, and it was much easier to pick up context in unknown projects this way. So for us, this system migration to ECS was really an opportunity as well to kind of stop and rethink the way we were designing our systems and to reconsider the different philosophies. So that's also a chance for you, if you're thinking about migrating your systems, to think about how you want your code bases to look and to apply these philosophies and take a step to rethink. All right, cost clarity. So we were running on Spot instances already before migrating to ECS. But only since running on ECS, we're able to fully leverage Spot. We're now running on Spot by default. This is possible for us on ECS for a few ways. One, like I said at the beginning, we have faster task startup now, so it's much easier to handle any Spot disruptions that might happen. If you do have a Spot disruption, it's also easier to actually mitigate it because you can launch more tasks and therefore avoid potential fallout. And we've also diversified our clusters because now ECS tasks are more abstracted and oblivious to the instances they're running on. It's easier to have different kinds of diverse instances and be not sort of locked into one specific instance type with one specific Spot price. So we save costs through running on Spot by default, and we gain some clarity through monitoring systems that we've built. And lastly, empowering teams. So the mission of the platform team at Mapbox is really to empower other developer teams to running their code successfully on AWS. And running on ECS has made this easier for us in a few ways. We gave our developers better tools to launch code faster, and we gave them more ownership over costs and spendings with a range of monitoring tools that we built. So these are the non-obvious benefits that we found in our migration to ECS. Tomorrow morning, I'm giving a breakout session. It's actually CON356, not CON405. And I'm going to give you a lot more technical details on how we managed this migration journey over the last year. Thank you all so much.
Thank you very much. Wow, thanks. And it's always great to see customers evolve their usage of a service. I mean, we have seen this with EC2. We've seen this with things like Lambda. We're seeing this with containers. In the early days of containers, people used to run simple deployment jobs. They moved on to slightly more decoupled services, microservices, but taking advantage of things like Spot, taking advantage of diverse instance types and not getting blocked by a pool getting constrained for a particular period of time. Those are things that even we had not thought of when we launched ECS. And a great example of that was that earlier this summer, we added the ability to launch Spot fleets directly from the ECS console because folks like Francisca and company had started doing that as a way of running their infrastructure. So, show of hands. Who knows what this is? Where this is from? 1. Oh, you're not allowed. 2. Great. A few people. Yes. So for those of you who don't know, this is from a song that Frodo, I think it was Pippin, and Sam sang when they set out on their journey to Bree, where they were going to meet Gandalf. It's from Lord of the Rings. I like this, and it's particularly appropriate for this because I believe it has 2 messages. One, it is the start of a grand journey. Hopefully this one doesn't end up in Mordor, but still. And many people who are starting to adopt containers, especially those who are coming from traditional monolithic infrastructures and using containers as a way to build new waves of applications, for them it is kind of in that way. But the second comes from people who have built cloud-native infrastructures before and are evolving them, and quite honestly for us. And that is that as you go down new roads, you often find that you get to the roads that you already had traveled on. So so if you think about it a little more, it's basically yes, this is new, but you can always learn from lessons from the past. And we find ourselves doing that again and again and again, which shouldn't be a surprise, but it's good to keep that in mind. So 3 years ago, I stood, well, not in this stage, somewhere in the Venetian, talking about the preview of ECS. We had just launched it, over those 3 years, our customers have taken us along a journey. We've developed features. You'll hear about some of them today. You'll hear about some of the journeys that our customers have taken and some of the kinds of applications that they're building. But let's start where it began. So early 2014, this is about a year, 9 months after Docker got launched, we started hearing a lot about, hey, Amazon, build us a Docker service. For those of you who've seen me talk before, I often say nobody ever asked us for an LXC service before that. So there must be something here. So we started paying attention. And it became clear that there were a few reasons that people cared. One was the polyglot packaging. You could write applications in whichever language you wanted, package up its dependencies. You could ship it, and the runtime was portable for the most part. It ran on any modern Linux kernel. It ran on your laptop, it ran on your VPS server somewhere, it ran on AWS, it ran somewhere else. And again, for the most part, these things just ran the way they were supposed to. And perhaps most importantly, it was pretty easy to get started. There's this Docker book that a few people have written. If you get started with it, you're probably done and running your first containers in a few minutes, in 10 minutes or so. It's not that difficult. But then comes reality. You have to stitch together applications. Applications aren't made of single containers. Applications don't get run by one team. Usually, they have more than one team. If you're a large company, you are not in the same place. You have multiple applications, potentially different compliance regimes, and different ways of building software. So how do you solve these problems? And for that, you have to jump into the deep end right off the bat. So when we started thinking about how to build a container management service, there was really nothing out there. You had HPC schedulers that had been around for a while, but they solve a very specific problem. You had Mesos and Yarn, and Mesos, at that time in particular, had a lot of its heritage in HPC systems. That's how they had started. But it had built a two-level system that was nice. OK, let's take a look at that. Google had just published the somewhat now well-known paper on what was called Omega, which not only had insights into how they were running their cluster scheduler, but how it compared to other systems. And you also had the first few sort of native container management systems. There used to be this thing called Flynn. I don't think it's around anymore, or maybe. But it was pretty fascinating. It was complex, but it had abstractions that seemed to make a lot of sense. So we looked at all of those, tried to understand what we could learn from them and how they might apply to the way we wanted to build our services. But in the end, what we really ended up looking at was the way we were running our own infrastructure. EC2 had been around at that time for 7 years. It operates at massive scale. It solves a big scheduling problem. So there are lots of lessons to be learned. But we also learned from the abstractions that people had started using to run containers. And so for us, that meant building a foundation. And the foundation was you had to maintain, you did not want people to run their own cluster managers. Like the container management system is fine. But nobody wanted to run Zookeeper. Nobody wanted to try and figure out how to spin up a cluster and try and figure out placement, or at least most people didn't. So we needed to solve that problem. Our customers have been running on EC2 for years. EC2 has well over 1 million customers. You needed to they were familiar with the APIs. They were familiar with how it worked. So you needed to build something that they could get started with really quickly. And perhaps most importantly, they wanted the same capabilities that EC2 had. They wanted the same power. And we are still not there yet, but that's what they told us then. And so that was ECS. We started, the preview was announced 3 years ago. We went GA a few months after that. And we've kept releasing features. Since then, probably, if I remember correctly, about 55, not counting the ones this week. Since then, and this year we've been busy, including, I'll call it a couple, because they are somewhat recent and you may not have heard about them. So some months ago, after Windows added Docker support, we announced a preview of Docker for ECS, or Windows containers for ECS. This week, we released an optimized army that we've been working with folks at Microsoft and Docker on to improve start performance, improve stability, get the networking to a place that we were comfortable. And we consider this as generally available now. Next week, we'll have blog posts and marketing material that will tell you that Windows containers on ECS are GA, so you can run them in production. And we're super excited to see what people are doing. There are people who run Windows containers, and not just for trying to migrate monolithic applications. There's a bunch of .NET developers who really like that platform. And there's a couple of other, I already mentioned the Spot Fleet integration in the console. The other thing that I will add is regional expansion. We have customers like Mapbox that are now running in 7 regions, and I think 8 hopefully sometime soon. But there's still a couple of regions commercially that we are not available in, and some of our non-commercial regions like GovCloud that we need to go in. And our hope is that very soon we'll be available in every AWS region globally. And then every new region when it comes up, ECS and ECR will be there by default. So why do customers use ECS? These are some of the obvious benefits that were mentioned earlier. The first one is speed. In the cloud, speed tends to be the reason why people move to the cloud. Agility is what Anytime you talk to someone, especially larger enterprises, why using AWS? Oh, we can move a lot faster. That's cool. Containers seems to have made that even more tenable for customers. And so what happens when you are the world's largest restaurant company? That's McDonald's. And that you have to develop a new platform to give customers more burgers. Apparently, people like eating burgers. I do. And to talk about how McDonald's solved that problem and how they built a new platform to get food delivery to customers in less than 4 months, here's Tilina Gunasinghe from McDonald's.
Thanks, Deepak. And it's always amazing to see the level of engineering and innovation that goes into building Amazon Container Services. Good afternoon, everybody. My name is Tilina Gunasinghe. Hope you guys are enjoying re:Invent. I'm here to talk about how we at McDonald's use ECS to massively scale our home delivery platform. So let's get right to it. Here's some interesting facts about us. We have about 37,000 restaurants spread across 120 countries globally, and we proudly serve about 64 million plus customers on a daily basis, right? So this probably will give you an idea of our scale. And mind you, this is also distributed scale with a very large customer network. So let's talk a bit about our home delivery solution. Think of this as you as a customer using a third-party delivery platform, such as Uber Eats, to order and get McDonald's food delivered, right? So we work with multiple delivery partners. Here in the US, we use Uber Eats. In countries in Europe, as well as countries in Asia, we use other partners. So I've kind of used like a generic flow to go through the experience using our own mobile app. First, the customer picks a restaurant, goes through basically the menu of the restaurant, right? So I've used our signature crafted sandwiches, right, to illustrate. Next, you build your order basket, right? So this is based on what you want to eat. And then you check out at this point, right? Once you check out, when the delivery network's driver or rider is close to the restaurant, the order is released to the restaurant to make your food fresh, right? Once the food is then delivered to the driver then basically comes and delivers to you. So this is basically the business solution that we used ECS to really scale. All right, so what were some of the business requirements, right? So Deepak mentioned that at the beginning, the new norm is speed to market, right? So you go from an idea to a concept to development to massive scale, and this took us about 4 months to do, right? And that's kind of the new norm, right? So you want a concept, you want to really scale, right? Second thing is the scalability and reliability, right? So we certified our platform for 250 to 500,000 orders for the peak hour. Mind you, the peak hour happens 3 times for us every day, right? You got to eat, there's breakfast, lunch, and dinner, right? To put this in perspective, this equates to about 20,000 transactions per second, right? So that's the scale that we're talking about here. Multi-country support, this is again not just a single country. You got to work in all those countries that I mentioned, right? Those countries have different business rules and also different delivery partners to work with, right? So that was another thing. Finally, the cost sensitivity for us, right? So again, we're not selling big screen TVs through this platform. You're talking about an average check of about $3 to $5, right? So that also is a pretty critical target for us to hit. So let's go under the covers in our architecture, right? Use the pointer here. The experience that I mentioned starts over here with a third-party delivery platform. All our APIs are then hosted through a API middleware, right? This consistently follows the API gateway pattern with RESTful APIs. They're then wired through ALBs to the heart of the solution, which is ECS, right? We have a range of microservices that are running here. And for simplicity, I've used 2 services here, right? Think of, let's say, one of the services requiring one of those customer-facing, mission-critical, highly scalable, highly reliable, highly performant characteristics, right? Then you could, through ECS, use a scale profile, a runtime profile with the correct auto-scaling policy, task placement strategy to do it. The next service, let's assume that it's like a complex event processing type scenario, where maybe scalability is not the number one goal, but optimization, workload optimization is the key, right? So in a situation like that, you could use like a bin packing strategy, and we'll double click on this in a second, right? So ECS is the heart of the solution. Of course, it gets connected to the restaurant. And under the covers for all our eventing, we use SQS, right? So think of, again, two microservices wanting to talk to each other through an asynchronous pattern. We use SQS. It's not just about scale, though. It's also performance, right? And the days of like your transactions taking 1 or 2 seconds have gone, right? The new norm is under 100 milliseconds, right? And that's what we achieved using Elasticache in this case, right? To keep a lot of things in memory. Again, don't think of this as just read workloads. This is read and write combined, right? And then that's backed up by RDS and S3. So hopefully that will give you an overview of how we really scaled with ECS. All right, so what are some of the architecture principles we use, right? So number one is getting your microservices strategy right? So this will help with your containerization. And this is, again, not a talk about microservices, but having a clean API, having a good service model behind it, right? Having a level of isolation for your data model, independent deployments, right? So those are some of the key microservices principles that we used. Then that gave us the basis to containerize this right? Then the magic of ECS kicked in when you use that containerized and orchestrated for scale, right? And we'll cover that in a second. Werner covered this third point, so I'm not going to belabor it, right? Use platform as service components as possible instead of doing your own clusters, right? It's not for the faint-hearted. So therefore, you get scale out of the box with some of these things. Synchronous and event-based program model, I think for the developers in the room, this is obvious, right? Pick a good programming model, develop your microservice on that, then use containerization. So these were some of our key principles. So here's now under the covers a look of how did we really achieve this, right? There's two constructs that we use out of the box through ECS. Number one is the auto-scaling policies, right? You got to figure out a good way to trigger the auto-scaling, right? So think of like using something like a Cloud Watch alarm to do it, right? That's number one. Number two is what we've discussed here, right? These primitives really helped us to really scale, right? Again, I'll walk you through an example here. Assume that there are 3 services and the scale properties of all 3 services are different, right? Number one is that customer-facing, mission-critical, highly performant, highly scalable microservice, right? We used the spread strategy for that. So with spread, ECS basically spreads your workloads across the availability zones, right? So task placement with spread really helped us scale. Number two, assume that workload optimization is what's important here, right? So for that, we use bin pack, right? So bin pack basically optimizes your infrastructure, will help with the cost sensitivity goals that we had, right? And number three is if you want process level isolation, assume that, for example, the US processing versus the European countries processing need to be isolated, we use member of, right? So this is how we used with auto-scaling policies as well as task placement strategies to really scale. All right, so some final takeaways, right? I won't belabor the point with microservices again. Scalability, reliability comes with microservices, right? We really hit north of 20,000 TPS with this solution, right? So under that 100 milliseconds. And again, to put this in perspective, think of this about 1.7 billion transactions a day, right? That's kind of the scale. Moving to containers, if you have not done it, do it. It will simplify your life quite a bit. And then finally, kudos to Deepak and the team for giving all of these features out of the box with good integration with the whole AWS stack as well. For example, ALB integration comes out of the box, right? And your dev pipelines also easily integrates. So hope you guys enjoyed it. Thank you very much.
Thanks. What? Thanks, Selena. So you have heard from 2 customers. There's a whole bunch. They range from from nimble startups to some of the largest companies in the world running a variety of workloads. There are people just using containers for deployments, the people running containers at scale with massive microservices, the people just doing batch jobs. And one of the things that we have learned is that there's no one-size-fits-all solution, but if you give people a set of key primitives, they can build really, really powerful applications, as you just heard. And what does this translate into usage? I'm going to use ECS usage as a microcosm of container adoption in general. So since 2016, since January of last year, ECS user growth has been 462%. And as you can see, the growth in 2017, it just took off. And I suspect it's not going to slow down anytime soon as container management systems become more robust. Right now, at this point of time, there's over 100,000 clusters under management by ECS. So that's ECS has a regional control plane. So if you take all the regions that ECS operates in, those 8 or 9 control planes are operating over 100,000 clusters. These 100,000 clusters translate into millions of instances. So some of our clusters are small, couple of T2 instances. Others are you have people with tens of thousands of instances in a single cluster, doing some very interesting running some very interesting applications. And this is probably the number that took me the hardest, that was hardest for me to get to, which is hundreds of millions of new containers are being launched. These are new containers, not existing that are already running, because there's lots of long-running applications, and that's every week. Every week, there's hundreds of millions of new containers being launched, and that's just with ECS. There's customers running all kinds of container management systems. You can only imagine what overall broad adoption is like. Having said that, you heard about some pretty exciting applications, mapping, getting a food delivery application out in just a few months. But what we also find is that there are a bunch of customers who use containers in a much more pragmatic way. They're pretty chilled, like the AMA over here. And what they try and do is, okay, let's not try and throw the baby out with the bathwater. Let's take what we have. Let's solve a critical business problem, and then leverage containers for their strengths to get that. And to talk about that from the Washington Post, Patrick Cullum.
Thanks, Deepak. So I'm excited to be here today. I want to talk about how the Washington Post built a new software as a service business powered by ECS. I think it's a really interesting story, and it's one that really I'm excited about. So if you're not familiar with the Washington Post, we're a major news publisher with more than 95 million monthly visitors and 1 billion page views. Over the last few years, the Washington Post has seen tremendous growth, and the engine behind this growth has been an equal focus on excellence in journalism and technology innovation. Because technology innovation is such an important part of this growth story, we wanted to take the same technology that powers the Washington Post and build a business out of it. And so we launched a business called Arc Publishing. At its core, Arc Publishing is a fast and efficient CMS for modern publishers. Speed and innovation for readers, newsrooms, and developers are the core goals of Arc Publishing. Many years ago, the Washington Post had an architecture very similar to other major news publishers. We had a commercial monolithic CMS, and all the content was stored in one application and database stack. The problem with this architecture is that it makes innovation difficult because it reduces the flexibility to experiment with new ideas. We gradually migrated to a new architecture where each content type is stored in its own microservice. So in this example, we have a video, story, and photo service that are all separate. They have their own application and database stacks. The benefit of this architecture is it allows us to independently develop and deploy each of these. And this architecture increases the rate of experimentation, leading to higher quality product. When we launched Arc Publishing, we wanted to bring this same innovative architecture to our customers. Because our microservice architecture was designed for just a single tenant, the Washington Post, there was no native support for multiple tenants. So this was a real problem for us. This meant that each Arc Publishing customer would need their own copy of each microservice. Although we considered re-architecting all of our services to be multi-tenant, we realized that would significantly delay the launch of Arc Publishing. So instead, we decided to clone the environments for each Arc Publishing customer. This allowed us to quickly iterate with real users and to launch the business, but it made scaling the business very challenging. To put these scaling challenges into context, we needed a platform that supported more than 50 deployments an hour across 100 unique microservices. And in our infrastructure, this translated into over 150 ECS cluster instances and many thousands of Docker containers. Adding to our challenge, we had a DevOps culture, which means there was no dedicated operations team to manage this infrastructure. And unlike a traditional software company, we had limited engineering resources to focus on these scaling challenges. To solve these scaling challenges, we built a container platform powered by ECS that we call NILE. NILE takes Docker containers as the unit of deployment and schedules those containers across multiple ECS clusters. NILE made it easy to port our existing technology to Docker containers that can then run on ECS. NILE also keeps track of tenant containers so that we can quickly update a particular microservice across our entire environment and keep that rate of experimentation high. The NILE platform is also designed for reliability because Arc publishing customers are some of the top media companies in the world with very demanding uptime and performance requirements. Building NILE and ECS allowed us to take our limited engineering resources and focus those on building new customer features instead of managing infrastructure. And we're able to do this without a dedicated operation team to manage our environment. Thank you.
I wonder why that 2017 graph was going up. It's been a busy year for the Washington Post, I think. So, we are starting year 4 of our journey, and when I say our, yes, I'm talking about container services on AWS, but this is pretty much year 4 of meaningful container adoption as well, because Docker got launched March of 2013, and that adoption just started growing, has started accelerating, as you saw in the adoption graph for ECS a few slides ago. Now, our customers are running very, very meaningful workloads. You've heard from 3 of them today. You're hearing from many of them throughout this conference, and people who are talking about it in much more detail. So customers are, as I said, customers are running deployments, they're running batch jobs, they're running microservices, they trust us to be reliable, they trust us to scale, and they trust us to be secure. So what does this mean from a production application standpoint? The first one is getting the right certifications. Not everybody here cares about them, but there's a whole bunch of people who do. So about a year ago, we started working on getting the same certifications for ECS and ECR as we have for EC2. We started off with ISO. Somewhere along the line, we got the Infocom certification, PCI, HIPAA, and I think last month we got SOC 1, SOC 2, and SOC 3. That happens in a short period of time because you've built something with the right right problems and the right challenges in mind. You want to be able to scale. You think hard about how you want to build your applications, how you want to operate them. And what it also allows us to do is then go and tackle harder certifications like FedRAMP, which is something we're working on right now. It also allows us to do this. So as of this week, we are adding ECS to the EC2 and EBS compute SLA, which is a 4.9 SLA now. So for those of you who care about SLAs, we have one. It's something that comes up, so I just wanted to bring that up. As an engineering team, as a service team, our goal is to make AWS the best place to run containerized applications, and which ends up for us meaning you have to think about containers as a fundamental compute primitive, not necessarily something that you just orchestrate on top of EC2 instances. Our primitive is not a container, actually. It's a task. For those of you who don't know what a task is a collection of containers that you put in a single file that get placed together, have common metadata. And everything that ECS does primarily, it operates at the level of a task. So we started going down that route some time ago. The first one was adding IAM roles. Probably the first feature we heard of when we launched ECS. When am I going to get IAM roles for tasks? So we worked on that. We did that. The second thing we probably heard was, how can I auto-scale my task? It's very fine that you allow me to scale my EC2 instances, but that doesn't really help me, to a point. But what I want to do is react to traffic on a fixed set of instances or a small number of instances and be really efficient at using them. We also had to work with the load balancing team, and the culmination of developing task load balancers became ALB and now NLB. So new kinds of load balancers that we built out of the centralized ELB team. And the last one, and I'm very unabashedly very partial to this feature, is task networking. And I'll talk about that one a little more. The reason this is probably the favorite thing of mine that we ever launched was because it started with ASCII art. It was a proposal that we submitted to GitHub about 9 months ago, I think. I forget exactly. And the idea was, hey, we have a proposal to give you, to solve a problem that we'd heard from customers. And the problem was, we want direct addressability of tasks that are not on the same host. And that is not trivial. And I'll tell you, that doesn't work very easily, and I'll tell you why in a second. And we started thinking about how we could do it better. How could we give people better performance? And how could we give people an EC2-like networking experience? It turns out we have this networking fabric called VPC. And the solution was, OK, let's try and figure out how we can bring VPC into the container layer. And that took some work. And let's go through what we are trying to do. So over here, you see, let's assume this is one host. That's the second host. You have a bunch of containers in them. They're all connected via a Docker Zero bridge. That's how they communicate. Within the Docker Zero bridge, each container gets its own IP. They're in that namespace. But that namespace, that IP is only relevant in the context of that host. It does not mean, so if you try and take this packet and send it to here, and you address that IP address, it won't work, because it's going to try and, that's the IP address you need to go to, the way Docker networking works. And our goal was to try and figure out, how can we take, oops, sorry, wrong button. How can we take this packet, get it over here, by directly addressing that IP address? So we built a whole workflow. It starts off with the agent and things we built into the agent, but it's a workflow that's managed by the ECS control plane. The first thing we did was take Elastic Network Interfaces. Before an Elastic Network Interface is attached, your primary ENI is in the default namespace. ECS then attaches that ENI to the host, and then the new ENI Eth1 becomes the default namespace. And then we wrote a bunch of CNI plugins. You can get them on Docker on GitHub. And we basically move this ENI into a new namespace, address it, configure it with addresses and routes. And that gives you a ton of benefits. Well, the first benefit is you can take this packet and send it here by directly addressing that IP, because now the IP is actually the IP of that, well, in this case, a task. You can attach, because now you have an ENI with a primary IP attached to it, you can put security groups on it. You get every feature of VPC, including flow logs. You can, I think there's a whole bunch of VPC features announced at this reInvent. You can take advantage of all of them. And it really makes, we think it's a really powerful feature. The good news is you don't have to set up anything. The whole workflow is managed by the ECS control plane. So this, as I said, it's probably the favorite feature of ours that we've launched this year. Taking that forward, what else can we do to make it easier for running applications? For those of you who have not, there's a demo of native service discovery from ECS. Yes, we've been here, many of you will say, finally. It is true. But our goal is to do something similar, is manage that service discovery experience just the way we do load balancers, for example. So you build your app, you give services a simple name, a common name, and the name resolves to an IP endpoint dynamically. ECS manages the whole lifecycle. So you activate it during a service deployment. We update the service registry based on a naming convention. We worked with Route 53 to basically, they built us a service registry and a naming service, and ECS manages the rest. We take things in and out of private hosted zones. We give them the health checks. We're actually building new health checks for this. And what it allows you to do is take advantage of the scale of Route 53 and the feature set, but without having to set up the service discovery yourself. It's just built into how you operate services. So we're pretty excited to give it to customers. There is a live demo in the talk. You can probably go to the booth and get it as well. And we hope to release it early next year. The second thing that that you'll probably get to see at this reInvent, and that's going to come out very soon, is integration into code pipeline. So for people doing end-to-end deployment, in the end, developers actually don't care about ECS. They just want to write code and deploy it. And like any standard deployment pipeline, this is kind of how code pipeline works. You have a source repository, you have a build system, and you have a deployment system. Till now, ECS was not a deployment target for code pipeline, but now it is. And the way it works is, and this is the console, you go to the console, you select a source provider. It could be GitHub, it could be Code Commit. You select a build provider. I actually don't know what other build providers Code Pipeline supports, so Code Build. And then you select a deployment provider. Used to be code deploy and potentially others. Now you can choose ECS. What that means is you can deploy directly to ECS. If you make an update to your code, this uses the ECS update API to update your services. And so you can get a very clean pipeline. And your developers can keep writing code and deploying it, and let Code Pipeline do all the heavy lifting. It allows you to set guardrails, because with Code Pipeline, you can set up rules and deployment workflows. And this will keep evolving, and we are super excited to have this in the hands of customers as well. So where is the road going from here? We've got to this point. We've got task networking, we've got task load balancing, auto scaling, IAM roles. You also heard about service discovery and deployments, but they're pieces of the puzzle. You're still running this on EC2. A good analogy to this is, when is the last time you ever asked somebody at AWS, I have an EC2 instance, when I run the run instances API, which server in an AWS data center are you putting it on? Nobody asked that question, at least. I've been there 9 years, nobody has asked me that. Maybe 1 or 2 people. They say, can I go touch one? So clusters are fundamentally a relic of physical infrastructure because you need to put boundaries on things to be able to run on them. They end up having a master node that becomes a traffic cop as opposed to a single control plane. So what people want is, much like EC2 gives you an API to get an instance, you want an API to a container, or in our case, a task. And you heard about this in Andy's keynote, you probably heard about it in Werner's keynote, and that's AWS Fargate. So we started working on Fargate a while ago. Once we understood what it meant to operate containers at scale and manage that scalability for all the customers that we had. And what Fargate does, and it's best explained with this diagram, is let's assume this is 3 EC2 instances in 3 availability zones, and you have a bunch of tasks running on them. And you spin up those instances, you put them in an auto-scaling group, and you schedule, if you're very smart, you're using placement constraints and all our placement logic to schedule instances based on some business requirements. But guess what? You don't have to do that anymore. All you do is launch tasks. How we optimize it, how we give you great start times, how we manage it becomes a declarative signal you give us, and we run that for you. And I think it sounds simple, but I think we still haven't figured out how customers are completely going to adopt to this world where a lot of the features in container management are around scheduling. You don't have to do that anymore. The scheduler shouldn't be what you think about. You think about your application and the application behavior. Scheduling shouldn't matter other than figuring out which one gets more importance than the other one, or whether you want it highly available or make it run fast and have low latency networking. Those are problems that we want to solve. So let's take a look at it. Here's a little demo that I'm going to try and do. Let's see if this works. It's a video. I'll talk to it. I'll kind of give you a sense of how Fargate works. I'm going to use the ECS CLI for it. The ECS CLI got updated this week to support Fargate. And the ECS CLI, for those of you who have not used it, it's not the AWS CLI. It's an open source project that we have that uses Docker Compose as an input format to launch services on ECS. Did it work? Let's try that again. No, not yet. Let's try it one more time. Oh, it did. So the first thing you do is configure your defaults. So like any CLI, you have a configuration option. Fargate's only available in US East 1 right now, and Fargate is made available to ECS customers as a launch type. And a launch type could be EC2, or it could be Fargate. EC2 is what you do now, or what you used to do till now, and now you have the ability to do Fargate. And then once you have your default configuration set up, you launch and start building your environments. And underneath the hood, it's running a CloudFormation stack that's setting up your VPCs. All of ECS runs in VPC. You get native VPC networking. And so let's go to a running cluster while that's setting up and see what happens. So you see there's a couple of subnets that's standard. You have 2 files. One's your Docker Compose file, and which is wonderfully a WordPress file. In the ECS console, we actually have templates on some of these more common applications that you may want to run that you can just click through and start. And you can look at the ECS parameter file where you put in things like, let's go back to that when it comes. That's where you add your subnets. Those are the only 2 things you need to configure. The other thing you need to configure that's required in Fargate, but not in classic ECS task definitions, is your memory and CPU limit, because that's how we bill you. You pay for the CPU and memory that you reserve there by the second. So you put your 2 subnets in, because the subnet is your availability model in this case. And I'm an Emacs guy, so somebody else obviously did this demo. And you do a compose service, and you launch. And if you go to, and this is launching the service, let's wait a few seconds, and look at and you'll get a log at the end. So you want to grab the service ID so they can grab the logs to see if your service actually launched. We'll do that, and just do a Docker PS, I think. Look at the log, the task ID, hit that, and as far as I can tell, there won't be any errors, and this should have started nicely. Again, it's very boring, but that's what it's meant to be. Our goal with Fargate is to make the setup of your applications really simple, because all you need to do is define your task definition, figure out what the subnets that you want to launch your services into, and hit go. And all of this, if you're using the console, you get a bunch of templates to start with. I presume we'll probably have many of these templates on GitHub as well. So that was AWS Fargate. We've been working on it for a while. We're super excited about it. You don't have clusters. A cluster becomes just essentially a namespace that you launch applications into. It also allows you to do things like take an existing application. You can keep the same cluster name, change the launch type, create new tasks, and they can coexist with each other, except in one case, they're running on EC2, and in the other case, they're just running. Cool, awesome, we did that. But ECS is not the only game in town. Even as recently as a year ago, the definition of which was the game in town was a little tricky. There were many. Today, that's pretty much unambiguous, and that's Kubernetes. So a lot of our customers that started running Kubernetes, there's probably folks in this room who do that, and we were trying to figure out how best to support that. So we started off by working with a bunch of partners and joining the CNCF. The CNCF was interesting for multiple reasons. It was the home for Kubernetes. It was also the home for things like Containerd and CNI, which are very important to us, because those are ways that we're building our container services. But what really people wanted was, can you just run my Kubernetes for me? I hate managing the control plane. OK. I also want to be able to use ALB. I absolutely want to be able to use IAM, because I can't really be useful in AWS without that. And I still want to take the app that I'm running on my laptop and just move it to AWS and run it. Those are things that our customers are telling us, and you've heard this, and that's the wonderfully named Elastic Container Service for Kubernetes, or EKS, also the world's best kept secret. How does this work? We give you an endpoint. The endpoint is, behind that endpoint, we are managing your masters, and we are managing your persistence layer. You have a bunch of EC2 instances underneath that you own. They're running in your account. The master is the endpoint, and everything behind that is running in our world. You use you interact with it using the same tools that you used to today. So use kubectl or whatever tools that you want to use, and things should just work. We had 3 tenets as we started building this that came from some of the feature requests we had heard from our customers. One, I'm not building toys. I have production-grade applications. Give me the same kind of capabilities that I would expect for something like ECS. So give me a highly available control plane. And that was probably #1 thing for us. So there's no single master. We run across 3 AZs. We manage a persistence layer. We manage the updates without downtime. That's a big goal for us. The second tenet was provide an upstream experience. So we are right now, during the preview, we are starting off with 1.7, because that's where we were when we started. But in general, our goal is to be conformant to whatever standards of what a standard Kubernetes experience is, and be able to support that. And the last one is, if you want to use AWS services, you want the same integrations that, say, something like ECS has. And the first thing that comes to mind is networking. Nobody wants to run an overlay when you have something like VPC around. Now, there are some interesting differences between the way ECS was built and the way Kubernetes works. But we try to do very, very much the same thing. We have a CNI plugin. It should be on GitHub now and open source, now that we've launched. Your pods get the same VPC addresses inside the pod as on the VPC, so you're getting native addressing again. You're taking advantage of all the VPC features. And as I said, it's up on GitHub right now. The one difference is in the ECS case, you get a primary IP. In this case, you get a secondary IP. Because the way pod networking works, you'll run out of primary IPs pretty soon. You get multiple secondary IPs per ENI. So we're still giving you an ENI. You attach a secondary IP to it. What does that mean? You can't put a security group on at the IP level because it's at the host level. So we worked with Tigera. So you can use Calico's policy engine with EKS. You don't have to run the overlay network, but it uses the native interfaces that we are providing, and you get all the features that Calico does. So you get policy management through Calico. And the way we are going to do upgrades is when a new version comes out, whether it's a point version or a major version, we won't upgrade you automatically. You tell us when you want to get upgraded, when you're comfortable, when you've tested the new version out, for example, in a development cluster, and when you say go, we will. So it's a much more fine-grained, controlled upgrade process, unless there's a security vulnerability or something where we just have to upgrade you, and we'll do that. These are lessons that we have learned from EC2, which has been doing this for a while. So it's in preview now. From what I can tell, all of you and some more have signed up. So awesome. And we'll go GA in 2018. And there's one more thing. Everything I've described is kind of the old way of running containers. There's a cluster that you have to schedule onto. You still have to think about instances. You're paying for those instances. So one of the things we started working on, and we can't wait to get out, it's going to take some work, is to have EKS run on top of Fargate. So the mechanism that you will have is you pick your scheduler of choice. Right now you have ECS and EKS. Tomorrow there could be some new thing that comes up, and we are happy to support that as well if that becomes super popular. Underneath the hood, you have a runtime that's designed and will keep evolving to be the best runtime you can get for containers, and that's going to be Fargate. And we're super excited about how people will run all these applications and what else they will do with them and what they'll ask us to do. So, we've talked about a journey. It's a 3-year journey. Year 4 is just starting. We firmly believe that Fargate changes the way you think about how containers run in the cloud. It's a much more native experience. We have multiple scheduling and orchestration options. You pick the one that you like. And I'm looking forward to coming back next year with a new generation of apps at even perhaps bigger scale than what you heard today, although that's hard. And thank you very much.